Okay, hello SGD, Sacred Geometry and Decoded. I'll try to remember to speak up so it's not as soft. I'm going to look more at Sun, Earth, Moon, the Metre, the Cubit, the Great Pyramid. And so just a rough drawing, this is a pyramidion that they found next to the Red Pyramid, which is at a ratio of 3 to 2 height to width in regard to the Great Pyramid. But this pyramidion has the same general proportions of 7 high to 11 wide as the Great Pyramid. Those are idealised measures, but the pyramidion is 3 Egyptian Royal Cubits, wide at the base, or pi over 2 metres, and it is 1 metre high. Again, a 1 metre pendulum is 1 second. So with a pendulum, you cannot swing more than 30 degrees. That's because it affects the speed of it, or the frequency. But it just so happens that that section of arc, 30 degrees, 1 metre pendulum, is pi over 6 metres, or 1 Egyptian Royal Cubit. 1 second, 1 metre, 1 Egyptian Royal Cubit. The pyramidion, same proportions as the Great Pyramid, which encodes astronomical knowledge. 3 Egyptian Royal Cubits across at the base, 1 metre high. So metre and cubit. Now, 1 Egyptian Royal Cubit, or pi over 6 metres, is 1.7178, or 1.718 E minus 1 feet. There is a lovely relationship between the foot, the metre and the cubit. So English foot of 12 inches, and here we have a metre at the standard 1 metre by normal definition, which is the length of this pendulum. 1 metre to the end there. Okay, 1 metre plus 1 foot plus 1 Egyptian Royal Cubits of 50 pi over 6 metres. There's the chalk. Okay, 52.36 centimetres. All right. Metre plus a foot plus a cubit equals 6 feet to within 1/3 of a millimetre. That now is 6 feet, the idealised man. That's 216 grains, or 72 inches, if you're familiar with those numbers. But metre, foot, cubit, and the second. Now how does that connect to astronomy? Sun, Earth, Moon, the pyramidion, which is 1 metre high, same general proportions as the Great Pyramid itself. Alright, now, so if that's pi over 6 metres, or 52.36 centimetres, therefore from point to point would be half a metre, or just by definition is going to be, okay. So let's set our compass to that. Okay, get it right. That's just a little bit, this is just for illustrations, I'm drawing it with chalk, alright, so, but that would be 25 centimetres, 25 centimetres. Sun, Earth, Moon, the astronomy of a pyramid, the second. Okay, now, we've got a line over here, mark it. Alright, put my compass there. Might be a little bit light on the camera. Okay. Sacred geometry, what do we do next? We draw a vesica, out changing the compass. Okay, the vesica. Now, okay, no, I won't do that for now. Alright, now there is 25 centimetres, which is 0.2734 yards. So there is half a metre, 50 centimetres. Now this is 75 centimetres. I hope that last circle will fit in. Okay, so there is now 75 centimetres, which is 29.527 ... inches. Okay, now I'll finish that off. I'm going to be in shot. Yep, just make it in. Alright, so now we do a double vesica. So 25, 25, 25, 25 centimetres. Therefore, this now is 1 metre. 1 metre, which is 1.09, exact number, 361 yards. Okay, here we have inches. So this is how metre, cubit and foot connect together, and now sun, earth and moon. So let's begin. That is 27.34% of 1 yard. 27.34. The moon is 27.32, depending, okay, but let's percent the size of the Earth. Right. The moon orbits the Earth in relation to a fixed star every 27.32 days. It orbits on its axis every 27.3 days as well. That's why it faces the Earth. Now, there's a whole lot of other stuff, but okay, that's to begin with. Now, a full moon, the synodic month. So a sidereal month is 27.3 days. A full moon, a synodic month, is 29.53 days average. 29.53 inches. So time for full moon, one rotation of the moon around the Earth in relation to the sun. Sun, Earth, moon month, 29.53 days on average. And it just so happens if I multiply the diameter of the Earth by 29.53, I get the distance between the Earth and the moon. If I was to multiply the moon by 108 or 109, well, that works the other way as well. So the time, sun, earth and moon, 29.53 days. Ratio of distance, 29.53 times the Earth diameter times 29.53 distance to the moon. Okay, now 109.32. So if I multiply the diameter of the Earth by 108, actually between 107 and 109, okay, I get the distance from the moon to the Earth. So the moon times 109.3 will actually still work, or even 0.4 because of the elliptical orbit. That's the distance from the moon to the Earth. If I multiply the diameter of the Earth by that same number, I get the diameter of the sun. If I multiply the diameter of the sun by that same number, I get the distance from the sun to the Earth. Well, you could go on for now 27.3, 29.53, 1.903, just 2 orders of magnitude greater. And well, I forgot to mention, so pyramidion, the cap at the red pyramid, 1 metre high, 1 metre high, and 3 Egyptian Royal Cubits at the base. 3 Egyptian Royal Cubits, well, it also works this way. That's 1 Egyptian Royal Cubit, that's 1 Egyptian Royal Cubit, and that's 1 Egyptian Royal Cubit. The circumference of this circle is the base of the pyramidion at the red pyramid. The geometry of a metre itself is the height of the pyramid, which connects to seconds, as in 86,400 seconds per day. And if you multiply that by the max visible base of the pyramid and the height, including cycle and sockets, you get a perfect model of the Earth. Not a half model. 432 creates a half a globe, but 864 creates a full globe. It's all here, and it's all these particular, the numbers of Sun, Earth and Moon. Now, for instance, 29.53 days between full moons, 29.53 times the diameter of the Earth is the distance from Earth to the Moon. Now the vesica in whole numbers is the square root of 3. So there's the vesica, alright, so that's, if that is 1, that is the square root of 3. And the best whole number approximate of that is 265 over 153 equals the square root of 3. And the square root of 153 is, is it going to fit in? Well, 12.369. That's the number of full moons per year. 29.53 times 12.369 equals a year. Yeah, geometry, metrology, ancient sites, astronomy, the quadrivium, and yeah, so that's just a foot, cubit, metre. All these different ancient units of measure are all incorporating the same geometric, geodesic, Sun, Earth, Moon as well. It's not just related to the size of the Earth, it also has a connection. For instance, 30 degrees is 108,000 seconds of the compass. That's the top rotational speed of the Earth around the Sun, 108,000 kilometres an hour. And that's also the polar diameter of Saturn, which is Kronos or Saturn, Father Time. And yeah, seconds, metres, feet, cubits. Beautifully connected, beautifully connected. Have a good one.